Good day to all. Today we can discuss about ratio and proportion in mathematics. Why we discuss? Yes, ratio and proportion mathematics are used in resource planning. So we should aware about what is meant by ratio and what is meant by proportion in mathematics. Myself, Dr. B. Surishkumar, Department of Mechanical Engineering. Here, first the term ratio. What is meant by ratio? Ratio generally is calculated from the first quantity is divided by second quantity. What is first quantity? What is second quantity? Likewise, we may got the doubt. Here, I consider the two quantities which are 5 and 10. Here I can represent with the red color and yellow color 5 and 10. The ratio between 5 and 10 is mentioned as like 1 divided by 2 because 5 divided by 10 which is the ratio. So I can represent with 1 divided by 2 because I can simplify the 5 by 10 is equal to 1 by 2. And also we can inverse that one, which is the ratio between 10 and 5, which means 10 divided by 5 is equal to 2. Likewise, we can calculate the ratio. So now you may understand what is ratio. Then ratio symbol is to. So here 10 is to 5 indicates the ratio of 10 to 5. We can represent the same with the reciprocal or inverse. Okay, the inverse and reciprocal ratios are also available, so that the same term, which is 10 is to 5, is represented with the 5 is to 10. So 5 is to 10 is the reciprocal or inverse of 10 is to 5 ratio. Likewise, we can present the ratio values in resource planning problems. And also there in ratio there are different types available, which are simple ratio and compound ratio. What is meant by simple ratio? Which has two quantities generally. So 16 is to 4. The first quantity is 16, second quantity is 4. So 16 divided by 4, I can easily get 4. Likewise, 18 is to 6, which is also another simple ratio. I can divide the both the things, first quantity divided by second quantity. So 18 divided by 6 is equal to 3. And then another example also available, which is 20 is to 10. 20 divided by 10 is equal to 2, which is the simple ratio. And then another example also available with the ratio, which is known as compound ratio. What is meant by compound ratio? Yes, compound ratio is product of corresponding terms. In already with the simple ratio, I explained with the three ratios, which are 16 is to 4, 18 is to 6, and 20 is to 10. From this, what is compound ratio? Here I collect the first quantity from each simple ratio quantities, which are green color, 16 into 18 into 20. Likewise, I can pick from simple ratio, and I can keep this left hand side, and then I can collect the second quantity from the simple ratio, which are blue color. I can represent 4 into 6 into 10. Likewise, I may collect. So after that, what is meant by right hand side? There 4 3 2. Likewise, I may got after equal to there is a 4 3 2. I can make the multiplication or product of both the things with each other, 4 cross 3 cross 2. Here the compound ratio can be represented from the simple ratio as like 5760 is to 240 is equal to 24. So which is known as compound ratio. And another one example is simple ratio. Now you may aware about what is simple ratio and what is meant by compound ratio. And then proportion. Proportion is also available with the ratio calculation. Every engineer should aware about what is meant by proportion before going into calculating the resource planning. Okay, proportion is the equality of ratios, which determines the equality between the ratios. Here I can give you an example, which is 12 is to 6 is equal to 20 is to 10. Okay, which is the proportion, which may be equality of ratios between 12 is to 6 and 20 is to 10. Here the two terms are available. One is extreme and means. What is extreme? What is mean? Second question. Here you see the two statements are available, 12 is to 6 and 20 is to 10. I can create equality between two ratios, so that I can represent here is to symbol which represents the proportion. Here the first term and the last term, fourth term, here I represented with the yellow color. Both the things are called as extreme. And mean, what is mean by mean? Here the second term and the third term, here I represented with the red color. Both the things are means. So in proportion there are two terms available, which are extremes and means. Extremes are the extreme ends, which means first and, according to our example, the first quantity and the fourth quantity. And the means intermittent quantity, which means second and third terms. So here the proportion plays as like product of extreme is equal to product of means, which means here the extremes are 12 and 10 and the means are 6 and 20. If I make a multiplication with the extremes, 12 into 10, which gives 120, and I can represent with the multiplication in between 6 and 20, I can get 120. So the product of extreme, both the things I can get 120 is equal to 120 I can get, which means a proportion. So now you may aware about what is meant by proportion, and then which consists of some rules. There are 4 rules available with the proportion. I consider for explaining 4 rules with the example of 12 is to 6 is equal to 20 is to 10, which is the proportion because two ratio which has equality symbol. So which is the proportion? What is the rule? Yes, the rule 1. Here the first quantity or first term, the first term is 12, the second term is 6, third term is 20 and fourth term is 10. Here I represented for visualization with the different colors. The first term I represented with the red color, and the second term I represented with the yellow color, and the third term I represented with the green color, and the fourth term I can represent with the blue color. Here I can give you a rule 1 expression. The first term is equal to product of the second and the third terms and divided by fourth term, which is the rule 1 in proportion. Here what is the first term? I don't know, so that here I represented with the x. The second term is 6 is equal to the third term is 20 and the fourth term is 10. So I can get the first term from the rule 1. Here you see the x is equal to product of the second term and the third term, which means second term is 6 and the third term is 20. So that's 6 into 20, which can be divided by 4 the term. So the fourth term is 10. So 6 into 20 divided by 10 is equal to 120 by 10. From this I can get is equal to 12. Here I get the 12 value, what I considered as an example for explaining this proportion. So from this I can get the first term from the rule 1. If I don't have the second term, means how can I identify? Yes, the rule 2 is also available. It concentrates about the second term. So the second term is equal to the product of the first and fourth terms, and which can be divided by third term. So here I represented this example. 12 is to 12 is to x is equal to 20 is to 10. Here x is equal to the product of first and fourth term. Here 12 is the first term, 10 as the fourth term. So x is equal to 12 into 10 divided by third term. Here what is the third term? Which is 20. So 12 into 10 divided by 20, which can be represented as like 120 divided by 20. From this I can get the 6. From this second rule I can get the second term from the proportionality statement. So now I get 6. And then if I don't have the third term, what happenings? Yes, I can utilize the rule 3, the third term. Here you see 20. How can I get the 20 from this proportion? Yes, the statement is like I have like 12 is to 6 is equal to x is to 10. How can I get this third term, which is green color? Yes, x is equal to the product of first term and the fourth term divided by the second term 6. So from this I can get 20 divided by 6. If I simplify this, I can get 20. Yes, now I got the third term as 20. In my proportion, I don't have fourth term. What I should do, what I calculate? Yes, I consider the rule 4 is also available. The rule 4 is the fourth term is equal to the product of the second and the third terms, and which can be divided by first term. Here you see first term is 12, second term is 6, and the third term is 20, and the fourth term is x. So now I want to identify the fourth term, which is x. X is equal to the product of second term 6 and the third term 20 divided by first term as 12. So I can get the statement as like 6 into 20 divided by 12. From this I can get the fourth term, which is 10. Okay. Likewise, we can collect the unknown values between the proportions. So now you may understand what is meant by ratio. And yes, we can explain the proportion problems with a simple example. Here I consider 18 lathes are required to finish 4 jobs. And how many lathes would require to finish 14 jobs? Yes, for the reason I may utilize the ratio with the jobs is to lathe. The is to symbol denotes the ratio, and in between equal to symbol available, the equal to symbol indicates the proportion. So job is to lathes is equal to job is to lathes. Likewise, I may utilize the statement. Here 4 jobs are required 18 lathes, so that 4 is to 18 I represented. Then my question is 14 jobs, how many lathes are required? So that in right hand side 14 is to x. Okay, from this I can identify the fourth term, which is 18 into 14 divided by 4. From this I got 63 lathes. So if I want to finish 14 jobs, means I required 63 lathes. Likewise, we may conduct a resource planning with the ratio and proportion calculations. Now you may aware about what is ratio and proportion. How can we utilize that ratio and proportion for resource planning? Thank you all. If you are having any doubts, you may ask me through comment box. Thank you.